Welcome back. So we are learning about the linear circuit analysis, and we have seen in the previous series of videos to learn about the different systematic techniques like nodal analysis and mesh analysis. So the next very important and the most powerful analysis technique which is used for the analysis of the simple as well as the complex circuits is basically the Thevenin over Norton theorem. So using this, we can analyze, more complex circuits more easily. So the backbone of the Thevenin is basically based on the fact that if you have a very complex circuit, okay, and let's say there is a branch here and you want to find out what is the voltage drop across that branch, or for example, what is the current going through that branch or power whatsoever. And like we have the rest of this is a quite complex circuit. What we will do, we will take out that load branch out of our circuit. Okay, so this is our load. Okay, and then we will create an open circuit at that point. Okay, then we will calculate what is the equivalent resistance of the circuit if we look from that end. Okay, we will compute that and we will put that in series with our load. Then we will also calculate what is the voltage drop across that open circuit point. So we call this Thevenin voltage or open circuit voltage. And we will put that in series with the resistor here. So this will be Thevenin voltage or open circuit voltage. And we will connect with our load like this one. So to make a simple circuit. So this is called basically Thevenin equivalent circuit. So once we have Thevenin equivalent circuit, so this is a very simple series network. So we can easily apply voltage divider, current divider, or simple Ohm's laws to compute the voltage drop here or current through the load element. So the important thing in the Thevenin theorem is that you have to find out the open circuit voltage or Thevenin voltage or the Thevenin resistance, from that end. So once you know that, we can calculate the equivalent Thevenin circuit. Another way to get the Thevenin resistance is like we calculate the open circuit voltage or Thevenin voltage, and then we make the load short and we calculate what is the current going through it. We call this short circuit current. So if we have Thevenin voltage and if we have short circuit current, so if we divide them, voltage over current, that will also give me the Thevenin resistance. So we can also calculate Thevenin resistance using this approach. So typically we use this approach when we have basically dependent sources within our circuit. For the independent, we can easily basically apply the simple concepts that we have learned in the earlier series of videos about analyzing the series and parallel combination of circuits to get the equivalent resistance. And if you want to make a Norton equivalent circuit, so it is similar. The only difference between Thevenin and Norton equivalent circuit is like we get our load, we get R Thevenin, okay. For the Norton case, this is also called as R Norton, but R Thevenin, but it's same. There is no difference, okay. And in Thevenin, we calculate the open circuit voltage. In Norton case, we make the load short and we calculate the short circuit current. That is basically called as Norton current. Okay. So in this case, we will use the Norton current, and then this Thevenin resistance, this will come in parallel with that current source. Okay, Thevenin or Norton resistance. Okay, so this is a Norton equivalent circuit. So again, we will get a simple circuit. We can use this to analyze and to get the voltage and current, okay, across your load as per the requirements. We can also get a Thevenin or Norton equivalent circuit using the source transformation. For example, if I have a Thevenin equivalent circuit, so like we have a voltage source and a resistor in series. So we can transform this to a current source, and the value of the current source will be voltage divided by the resistance. Okay, So this will give me basically this Norton current. And then this Thevenin resistance, they will come in parallel of that. Or vice versa, like if we have a Norton circuit, so a current source parallel with the resistor, we can convert this to a voltage source. That will be current values multiply with the resistance. So this voltage value is basically this one. And this parallel resistance, this will go in series. So either using source transformation or by computing the open circuit voltage or short circuit current, we can get the Thevenin or Norton equivalent circuits. Thank you so much.